Hello, everybody. It is Mr. McKee again, and this is going to be our YouTube explanation of Week 1, Review 2 for Conceptual Physics. All right, so again, we are reviewing some of the things that we did in the beginning of the last quarter, and they were so long ago that we need to kind of talk about them again. All right, so in a similar way to yesterday when we talked about average velocity, we have acceleration this time. And acceleration is just the change in speed or the change in velocity. More specifically, it's the change in velocity. So from a definitional point of view, okay, that acceleration is equal to the change in velocity divided by the change in time. So you may or may not remember that this triangle here is the fourth letter of the Greek alphabet, which is delta, which more importantly means change. Well, what does change means? Whenever we talk about change, okay, it's the difference, and the difference mathematically is subtraction. So we would say V final minus V initial. So it's always final minus initial. If we had the delta X, or the change in X, we would say X final minus X initial. If we had the change in energy, it would be the energy final minus the energy initial. So that's how we get that change. Now, we're going to divide that by T final minus T initial. Now, unlike some of these things, almost always, when we are talking about timing something, if I'm going to run a race, for example, I am going to be on the start line and I am going to push my start button. I'm not going to wait 5 seconds before I start to run. As soon as I push my button or simultaneously, I'm going to start to run the race, right? So usually my initial time is 0. So if we just have T final minus 0, well, we might as well just call this T, okay? So it's the change, V final minus V initial over time is going to be our acceleration. Now, you guys, there are times when you would say T final minus T initial. For example, if you're going to run that race and you're going to run 2 laps, and you run the first lap in 70 seconds, okay? So when you go around the first lap, you check your stopwatch, it's going to say 70 seconds. By the time you get to the end, let's say it says 150 seconds, okay? And you want to know, hey, how fast was my second lap? At that point, you would say T final, which is 150, minus my initial velocity, which at the beginning of the second lap would be 70, and now 150 minus 70 would give you 80, so your second lap would have been 80 seconds. Again, normally it's just going to be 0. Okay, so now, if you take a look at the first question in review number 2, it says a man starting at rest increases its velocity from rest to 4 meters per second in 8 seconds. Okay, so my final velocity is 4 meters per second minus my initial velocity. What is my initial velocity? Well, as you realize there, when you have a situation where you start at rest, that's 0, okay? 0 meters per second. So again, you guys, there are certainly times when you look at something and you're looking for a number, but it doesn't say a number. It can still be something like 0. Rest means 0. Stop means 0. And there are things like that that you will find in certain of these physics worksheets that that's exactly what it means. All right. So now we're going to divide that by 8 seconds. So we're going to have 4 minus 0, which is 4 divided by 8. And numerically, that's going to give us 0.5. And that is going to be meters per second, meters per second, because I'm dividing velocity, which is meters per second, divided by time, which is seconds. But this is not how we write that. And if you go back into the week 1 review number 1 worksheet, we can talk about how you divide fractions. And just to repeat that, okay, if we have meters per second divided by seconds, we can write this seconds in the numerator as a fraction. And when we divide 2 fractions, that's the same as multiplying by the reciprocal or the inverse. So we're going to multiply by 1 over seconds. And now we get rid of this. Meters times 1 is meters. Seconds times seconds is seconds squared. So the way that we write acceleration unit-wise would be distance per time squared. Distance per time squared. And for our standard distance and time, it's going to be meters and seconds, so meters per second squared. It could be, for example, miles per hour per second or something, but typically we're going to have it meters per second squared. All right, that is the answer to number one in your example. Okay, so now we're going to do problem number 2, and in problem number 2 it says how long does it take? So we're looking for time. Okay, now just like the equation from yesterday, which was average velocity is distance over time or displacement over time, we can change this around and we can say time is the change in velocity over acceleration, the change in velocity over acceleration. And if we look at that, now we can look at number 2. How long does it take for a car to change its velocity from 10 meters per second to 25 meters per second if its acceleration is 3 meters per second squared? Okay, so again, we're going to have our v final minus v initial over acceleration. Our final velocity was 25 meters per second. My initial velocity was 10 meters per second, okay? And we're going to divide that by 3 meters per second squared. Okay, 25 minus 10 is 15. Divided by 3 is going to be 5. And again, that's 5 meters per second divided by meters per second squared. And again, if you multiply by the reciprocal of the bottom units, you will realize that that is going to come out to, okay, the meters are going to cancel out, one of the seconds cancel out, it's going to come out to 5 seconds. Okay, now you might realize that since I'm asking for time that the answer is going to be seconds, okay, but mathematically that is how that's going to look, okay? All right, now we're going to move on to question number 3, and I'm going to do that, up here. And all right, so now this time we are looking, we have an object at rest, and it accelerates at 1.5 meters per second for 12 seconds. So again, we're going to take this equation, except we are going to solve for v, so we're going to have acceleration times time is equal to the change in velocity. So our acceleration is 1.5 meters per second squared times 12 seconds, okay? And 1.5 times 12 is going to give us 18. And now units-wise, we're going to have one of these seconds cancel out with one of those, and our units are going to be meters per second. And that's going to be our change in velocity. But that is equal to v final minus v initial. Okay, now this seems like a little bit of a tricky thing because our initial velocity is started at rest. So this would just be minus 0, which would just be that. All right, so our final answer, v final, is going to be 18 meters per second. Okay, now what can be tricky is if this was not 0. If that was not 0, then that could be a trickier sort of situation. All right, you guys, that is the answers to 1, 2, and 3. So your job now is to do equations number 4, 5, and 6. Now you're going to end up having some negative accelerations or negative change in velocities, but they're going to work out to have all positive numbers on each of those values. So good luck with that. And we will see you. We will see you next time.